Hi, good morning. In today's lecture, we are going to go ahead and we are going to start with limits and continuity. First of all, we are going to go ahead and we are going to talk about what are limits. Now, all of us at some point of time in economics have heard the word limit, have heard the word continuous function, right? But what is it? What do we mean by being a continuous function? That is something we're going to go ahead and discuss today. Okay. So the first thing that I want to do is understand what is a limit. This is just a little formal definition of limit. Try to read it out. Suppose f is a real valued function defined on the subset D belonging to R. We are going to define limit of function fx as x belonging to D approaches point A, which is not necessarily in D. What does this mean? It means that what we are doing is we are going ahead and we are saying that we are trying to approach a particular number. We can approach that number from any side. It means that we can start approaching it from the left-hand side, take numbers lower than that number, or we can approach the number from right-hand side. It means take numbers which are greater than that number. So we can go ahead and we can approach the number from left side, take numbers lower or right side. That number may not belong to the domain of x, to the domain of the function. That number may not belong to the domain of the function. What does this mean? It means that, for example, if I take a function, and I will show you this in the upcoming examples, x square minus 1 upon x minus 1. You notice that the denominator is x minus 1. So we know that this denominator is not defined when x is equal to 1. At x equal to 1, the denominator is not defined. So we know that this denominator is not defined when x is 1. Right? You will get, so we have, whenever we have a rational number, we need P by Q form such that Q is not equal to 0. But at x equal to 1, this Q is actually becoming equal to 0. So that's a problem. But still, we can go ahead and we can define limit of the function. So it's okay. We understand that x equal to 1 doesn't belong to the domain. Right? We have already understood what domain and range is. And we know that when we talk about the domain of the function in this case, the domain of function will be minus infinity to 1, union 1 to infinity. 1 is not included. Alternative way can be minus infinity to infinity minus 1. So we need to exclude 1 from the domain. The function is not defined at 1. But still we can ask how this function is acting when we are going closer and closer to 1. So we can go ahead and we can ask ourselves the question that what happens when I take values close enough to 1 but which are lower than 1. So for example, what happens if I go ahead and I take a value, suppose 0.9, right? Then I take the value, suppose 0.99. Then I take the value 0.999. So I am going closer and closer to 1, not 1. But I am going ahead to a value which is closer and closer to 1, right? So for example, let me just quickly open up a calculator. So 0.9 into 0.9 will be 0.81 minus 1. So in this case, the numerator is going to be minus 0.19. And denominator, if I put 0.9, I will get the answer as 0.1, right? So now if I go ahead and I just try to solve this thing, right? What will I get? I will get a value very, very, very close. This is also negative. I will get a value very, very close to 2. So my answer will be 1.9 here, right? Now you try and put this value, right? So you will have 0.99 into 0.99, and then you can just subtract 1 from it. So your numerator will be 0.0199, right? And then your denominator will be minus 0.01. So you will get 1.99 as the answer. When you will put this, you will get 1.999 as the answer. It means you are going ahead to a value close enough to 2, right? You are trying to go towards a value which is very close to 2. So as your value of x is going close enough to 1, I am not putting 1 here. I understand 1 is not part of the domain of the function. But I am approaching 1. I am going towards 1 by taking values closer to 1 but lesser than 1. These are all values lesser than 1 but closer to 1. And I am trying to understand how the value of the function is coming. What is the reaction here? How the function is acting. And we understand here that the function is going closer and closer to the value 2. Right? 1.9, 1.99, 1.999, very close to 2. So we say that when the function is approaching 1 minus, because I've taken all values lesser than 1, then my function is approaching the value 2. Similarly, I can check what happens when I again take values close enough to 1, but greater than 1. So I can go ahead and I can take 1.001, 1.01, 1.1. This is 1.1 is a bigger number, little bigger number. And I can see how my function is reacting, right? So if I just put 1.1, then I will go ahead and I will get the answer as, I will go ahead and I will get the answer as 1.21 numerator minus 1 upon 1.1 minus 1. So 0.21 upon 0.1, that means 2.1. When I will put 1.01, I will get 1.01 into 1.01, right? So you will get approximately 2.01 as the answer, right? And when you will be putting 1 point this, you can just go ahead and try this thing. So you will go ahead and you will get 2.001. So as you are going closer towards 1 from the right hand side, so if I just draw the number line, I have 1 here. I have 1.1 here. This is a little less, 1.01. This is even close to 1, 1.001. So as I approach towards 1, right, the value of the function is becoming closer and closer to 2. So when I am approaching 1, by taking all values greater than 1, the value of the function is approaching 2. This is my right hand limit because I have taken all values greater than 1, but reaching values closer and closer to 1. So what do we come? What have we attained? We have attained this definition. So we are going ahead and we are saying that, look, the function may not necessarily be defined at that point A. That A may not be part of the domain. I am not interested at what is happening at 1. वो मेरा point नहीं है limit में. I am interested in what happens when I go to closer and closer values, when I approach 1. When I go closer and closer to 1, what is my reaction? That is what is the function reacting? That is what I want to go ahead and see. And that is the concept of the limits, right? Okay. So as x approaches some point A, you are not putting x equal to A. That's not the point. You are approaching A. You are going closer and closer to a number A. Like here, I was going closer and closer to 1. Then the function approaches some number, say L, which belongs to the real numbers. So here the function was approaching, it was going closer and closer towards 2. It was becoming more close and close and close towards 2. So we can go ahead and say that this is how we can go ahead and represent it, that limit x tends to infinity. This is called x, or here x tends to A, sorry. So limit x tends to A. X tends to A means x approaches A. Then the function value, it goes towards L. It approaches L. So as x goes towards A, the function value goes towards L, and this is the concept of limit, right? So we have already done this example. Now, one thing you can go ahead and see. So if I go ahead and I try to simplify this function, so my function that I had taken, fx is equal to x square minus 1 upon x minus 1, right? If I go ahead and if I try to simplify this function, so what can I go ahead and write? I can write this as x minus 1 into x plus 1 upon x minus 1. And this will become simply x plus 1. So if you try to graph this function, the graph of this will seem very similar to x plus 1. So what is the graph of x plus 1? Y is equal to x plus 1. So when x is 0, y is 1. And when y is 0, x will be minus 1. So which means that I will go ahead and I will get something like this. That when x is 0, y is 1. So y is 1. And when x is minus 1, y is 0. And I can go ahead and I can join like this. And this is going to be my line. But there is just one difference, that this function, this is not defined when x is 1, right? When x is 1, it is in the p by q form where q is actually becoming equal to 0. So at x equal to 1, I need to draw an open circle representing that at this point, this is not really defined. At x equal to 1, this is not defined, right? And when we have this as x equal to 1, you can see that if I really put it in this here, what do I get actually? I will get y is equal to 1 plus 1, which is equal to 2. It means that another thing which I understand from here, that since x cannot take the value 1, right? X can't take the value 1. It means y cannot take the value 2. Because y is 2 when x is 1, right? So y cannot take the value 2. So it means that this 2, this is not part of my range. Isn't it? So what we are saying? We are saying that as we are going closer enough to 1, then the value is going close enough to 2. था जब हमने यहाँ पे 1.9 1.99 and so on sorry 0.9 0.99 लिया था, तो here values were becoming 1.9 1.99 and so on. And जब हमने यहाँ पर values लिया था 1.01 1.001, then you were getting values close enough to 2 2.01 2.001. So you were going closer to 2 as x was going closer to 1, but x equal to 1 पे not really this is defined. ये function है, original function is this, right? And here denominator is not really defined at x equal to 1. Okay, so now what we can go ahead and we can do here, so this is what is explained here. Okay, So try to understand the meaning of limits very clearly, therefore. It is the journey of the function. It's not the destination of the function. This is important. I am not talking about the at x equal to 1. So I'm not talking about the destination. Rather, I am actually talking about the journey. I'm talking about what happens when you approach something, right? So this is what this means. Okay, there are few observations here. The first observation is if the function is a constant function. So if I tell you, you know what, fx is equal to 4. It's a constant function. It always has the same value of 4. Then in that case, whenever there will be any limit x approaching any fx, it will always be a constant, right? So the limit of a constant function is that constant itself, right? So if fx is equal to 4, whether I put limit x tends to 1 fx, whether I put limit x tends to 5 fx, the answer will always be 4 because the value of the function is always 4. It always remains at 4. Another property here is that if fx is a straight line, if it is just fx is equal to x, right? Then whenever you take limit, that will become the value of the function. And that's very simple to understand. Fx is equal to x means what? That you are talking about a line like this, right? So whenever you will go ahead and approach any number here, suppose you approach 1 here also you will be approaching that number, 1 itself, right? So whenever fx is equal to x, right? So for example, I want to go ahead and I want to ask what happens when I approach 1 to this function x. It means I am taking values close enough to 1 but less than 1. So I take 0.99, I put that here, I get 0.99. I take 0.999, I put that here, I get 0.999. I take 0.9999, I put that in the value of the function, I get this. So function is also approaching 1 only, right? So when x is approaching 1, the function also approaches 1, right? Because the function is actually nothing but it is equal to the value of x. It is equal to x. Okay. Now the next thing that we want to understand is few of the properties of limits. The first property of limit is, so let's take two functions here. The first function is approaching L1 value when x is approaching a. The second function is approaching L2 value when x is approaching a. So in this case, you need to understand that in both of these, x is approaching a, right? X is going towards a only, and one of the function is taking the value L1 and the other function is taking the value L2. Now let's go ahead and let's take the first case. This first case here is when you have constant into the function and you're taking the limit. So the constant can come out of the function and you can simply have constant out and you can simply take the limit inside. And we know that this part, the function value when x is approaching a, that is given to us as L1. So this is simply going to be c times L1. It will simply be c times L1. Similarly, if we go ahead and if we come to the next one, so you have, addition or subtraction of two functions. So you can just open this up and you can have this limit x tends to a first function plus minus limit x tends to a second function, right? And this value is known to us as L1 and this value is known to us as L2. So you will simply get L1 plus L2. Okay, look at the third one. Now this is the product of the two functions. So product can also be applied separately. So first I have taken product and then we are taking limit. It is equal to first taking limit and then doing their product. So this value we know we had got L1. This value we know we had got L2. So we will have the answer as L1 into